Yeah. Oh, that's the general shape already. Yeah.
Oh, sorry, that was 2.
Mm.
Yeah,
Yeah.
that's basically.
Yeah, that's some good. Yeah. And if I ask you if it is for example 1/2, which is just the symmetrical from y, right?
Yeah.
Hmm. It'll be something like that. Oh, to give it an
Which
example of,
one
hmm?
over 2 symmetrical over y? Where are you talking about?
Oh, well, they give us 2 to x powered. We know a have to be greater than 0. So another kind of different graph, which is when 2 is 1/2 actually between 0 and 1. For example, if it is a 3 to x power, 4 to x power, 5 to x power, it all looks something similar as what you drew, right?
Yeah.
Yeah, but if it's 0.5 or 1/2 to x power, it would look something like this, right? Does it make sense? It's kind of symmetrical.
Okay, I guess so. Like the fraction version. So like it's like oh, so it's like if.
Yeah.
Okay, yeah. Okay, yeah. Sorry, I thought you meant like if x equals 1/2, and I was kind of confused for a second.
Oh,
But it's like y equals 1/2 to the power of x, right?
yeah. That's symmetrical with y.
Yeah. Sorry, sorry, I was confused about like where you're putting it.
This is well, you remember 1, you kind of remember 2 already. So this is the graph. And this is something, to give you an example about the cell phone. Subscribers here, well, that, they follow a exponential function. So this is the other one, symmetrical one. One word, 0, let's say 0.5 to x power. About this
There. Sorry, I was just clearing I was
Oh,
just clearing the board.
okay. So this thing is if we know the basic parent function. So this is to the one of the basic. This is 2 to x power. This is 0.5 to x power. And then if we know this two already, so we move on to transformation to transform for this kind. For example, this.
All right,
Example
so
5. No.
oh, and then oh right, -3. Okay, so we move it over by 3. Hang on, I need to undo that. Wait a second. Okay, yeah.
Ah, this is 2 to negative x power, right?
Yep, -3.
Oh, you already did
Oh
minus?
wait, sorry. I moved it to the x -3.
Ah,
moved it to the x -3, not sorry, that's too
ah.
bad. I should have done sorry, I was stupid about the transformation. Give me a second. Okay.
Yeah. Yeah, with the graph, we can see the domain range and the asymptote E. Okay?
Yeah.
Yeah. So with the graph, we can see the everything. Here is E. Have you learned E before? The
Yeah, it's
natural logarithm.
like E equals it's like 1 plus 1 over n. I kind of forgot about it because this year we didn't really discuss it that much,
Yeah.
but I did learn about it. Okay, 1
Yeah.
plus 1 over n power of n.
Yeah. If we substitute with all the numbers, then eventually you can
Yeah,
see that
it
it's
just it gets close.
2.718. I mean, there's a lot of that, like pi.
Yeah, it's just it's a lot of decimals.
Yeah, for example, trigonometry and also like the light or the sound or the like waves, visible, invisible, those all relate to somehow E. So pretty important number. And photograph this one. Just imagine it's 2.718, some approximately this number.
Okay, yeah, so then it would be like that, I guess.
Yeah.
Oh,
Hey, this one is yeah. And then you can
oh yeah.
use this
Okay,
parent function to change it, right?
I think
Use this one.
I
Use
kind
this
of
one.
under it. Oh right, yeah. And then you move it like 3. So like this.
Yeah. Are you moving to the left?
Oh right, it's supposed to be to the right, sorry.
Yeah, this is -3, right? But it's the right opposite to common sense.
Sorry, yeah, I know transformation, it's just taking
Yeah. Germans always take a second. Horizontally, it's against the well, what we think of.
yeah.
Yeah, this is e to x minus 3, right?
Yeah.
And they have a negative sign here, which is the entire thing already become all negative. Now that everything is positive, you make everything negative, which is symmetrical to x, I said, right? Isn't it?
Yeah, x minus 3, so then like it's just and then it's negative, okay.
Yeah.
Okay, so negative, let me think about this. Oh my God. Do you just flip it over
Yeah. Flip of one.
the
Yeah, basically.
the x-axis, right? I'm trying to
Yeah.
remember transformation rules.
Mm.
Like this, I think.
Yeah.
Something like that.
Yeah. Yeah. Okay. So now it's just the f negative x is symmetrical with y-axis, right? And negative fx is symmetrical with x-axis, right? Which means you flip over, right? And just flip it. Does that make sense?
Yeah.
Do you remember this? We're gonna use some
Yeah, that makes sense.
For example, how to solve this?
Oh, okay, give me a second. Let me clear it. Okay, so
Yeah. Yeah. Mm,
done.
yeah. 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 This one is true. Yeah, but it's just like it's yeah, it's right. And how about this one? Same sphere though. Um, so let me see. Negative x squared. This is okay. And negative 6x. As you said, this is e to the negative 3 power. And this,
I mean, isn't like the 1 over like a n equals a negative n or something.
yeah, that's good. That's good, this one. But what about this one? This one is totally right.
E to the power of 2x, isn't it?
Yes. E power of 2x times e to the,
Oh,
yeah,
sorry, sorry, that was bad.
it's okay.
All right. So I just took a second to like click, I think.
Yeah. Yeah, and then you solve it, right?
Sorry, it just feels like I keep making like basic mistakes and stuff, and it's really frustrating.
Yeah. Yeah, that's why we encourage to take it slow, although we have a lot of things to do. Yeah, negative 3 and 1. Yeah, I think that's
Yeah.
making sense, yes. What you want is e to 2x power, and if again, then this is 6x, right? This is making sense. Here's a word problem. Using everything that we learned so far.
Exponential problem. Okay. Okay, can I use a calculator for this?
Sure. Word problem, always calculator. Oh, yeah, substitution. Yeah.
Oh, okay.
Yeah, let's just leave it there.
Okay, yeah, it's just
Yeah.
yeah,
Just,
I don't need to like simplify it into like a bunch of
yeah, yeah,
fractions.
yeah. If you can do it to your like with calculator, you can do it. But now it's okay. Let's do B. Yeah, -6 power. Sure. How about C? Yeah, this is find different probability according to the.
Wait, okay, give me a second. Sorry, I need to like wait a second to like open like should I open like Desmos for this?
Uh, well, sure. If we can put in there, is it easy? Let's just type in and show the calculator. As long as you did it before, I think it'll be okay, right? I'm going to use the textbook one.
It's fine. I just opened Desmos. Okay,
Uh,
1 minus e
mm,
0.2 e. Oh, and CT, I guess. I don't know. Oh, okay. It looks like this. Oh, hang on. Let me zoom out a bit more.
hmm,
Yeah, look at this.
yeah. Is it similar? They look like something like this.
Huh? Did I do
29.
did I do it wrong? Give me a second. Let me
Did you
look.
type in something?
Oh, I forgot to put the negative on the 0.2. Sorry.
Oh, million.
So I keep missing like signs or something or like making tiny mistakes. I don't know why.
When we review something really quickly, yeah, it's kind of like that. We learn new things. That's what I think that's what. If it looks like something like this, then we can answer D. What values does f approach as t increases without bend in the opposite direction? This keeps increasing. What does y approach?
Y approaches infinity.
Y here is 1. Is it 1? This is 1. The scale here
Oh,
tells this
infin
is 1.
one. Sorry. I keep forgetting this. I keep forgetting like the scale.
This is the what? Well, this is like asymptote, right? Like well, f equals to 1 is the asymptote, right? Is the asymptote. So the answer would be, well, the probability is 1 at that time. Let's see, next one. Here, logarithm. Logarithm, you learned, right? Have you learned logarithm? That's the one.
Yeah, I learned logarithm. So it's like
Yeah, the
log.
inverse function. Mhm.
So it's like a log. Yeah.
Yeah, yeah.
That's the examples I always think of, like whenever I forget what a logarithm is. It's like log 10 100 equals 2 because it doesn't like.
Ah, good. But for me, the example is log 2, like A, 3 this time. Same spirit. How about A?
Oh, A, okay. If y equals log 3, okay. Am I supposed to solve this?
Yeah, it's related to that. I think this is okay, right? We can skip this.
Yeah, like
It's
I
just inverse function
yeah,
related to
we
that.
yeah, we learned it this year actually in algebra 2.
Ah, cool.
Yeah, like yeah.
How
Sorry,
about
sorry,
this?
keep saying yeah, but like,
Example 2 then? That's something you solve. I mean, you change from one form to the other form. One is exponential, the other one is logarithm.
Okay, change it. Okay, so
Yep. Mhm. Yep. There's the inverse function between these two. It's the same thing, right? We can skip this example 3. It's the other way around, right? You're familiar with this, right? If you change the other way into exponential form. Yeah, we can skip example 3, right?
yeah, I think so. Like I
This is the
think
inverse function. Same thing as almost as example 2.
I think I'm doing like pretty well with this one.
Okay. How about this? That's okay if you remember.
Oh, okay. Sorry, just writing that down. Like just keep me grounded, I guess. I don't know.
Yeah, yeah. That's good. That's a very good habit.
Hello?
Well, I think this part we can all skip, right? As
Yeah,
you learned this year.
yeah.
Domain, you also familiar, right? Domain of the
Yeah,
logarithm.
all the X values and stuff. So
Yeah.
like let me think. Let me think let me think what's out of the domain for this one. Oh, I guess if it equals, yeah, I guess if it equals, okay.
Okay.
Okay, let me think. Maybe. Sorry.
Yeah, try out
Oh
is a
yes,
good
I'm
way.
fine. Yeah. Okay, I was just like I was just like confirming that because because I feel like when x equals when x when it equals 0, it's undefined. It's always
Yeah.
like
Negative also undefined, right?
yeah.
Which means because in the basic function, when we did something like this, we always said this part have to be greater than 0, right? Whatever this part is, they have to be greater than 0, right?
Yeah, because like it's not like let me think. Sorry. Why am I saying let me think? Okay. So it's like log, so it would be like 2 to the power of something equals 0, but there's nothing that can equal that because like 2 to the power of 0 equals like 1 and everything else is like it's a number. It's not 0.
Yeah. And also because of this, they are always greater than 0, right? So that range is this domain, right? Because they are inverse function, right? Exponential and the logarithm. So if this is x is greater than 0, so this part has to be greater than 0, right?
Yeah.
So x greater than -3, right? Does that make sense? X greater than -3.
Yeah, it does. Yeah, it does make sense. It has to be.
Hmm.
Oh, let me think. Would like a negative version work like 2?
If less is not greater than -3, then this part have to be negative, which
No,
will
no,
be
I just mean like with like a negative with like a would like a logarithm work with a negative number or not? I don't think it would.
yeah, yeah,
I'm just trying to think about it like
yeah, yeah. At least our definition for logarithm doesn't really. It does have some of the problem, but it's not something that we study. So our logarithm, it's always greater than 0. That part. How about this one? B.
B, okay.
The domain, still domain.
It has to be greater than because both would like leave it like undefined.
Hmm. Oh, then it's -1 and to 1, right? X greater than -1, less than 1, is it? So that's the domain, right? Is it?
Yeah.
Okay.
Yeah. Oh wait, yeah, I think I kind of understand. Okay. Why is like why is it like
-1
why
to
is
1.
lesser why is X lesser than 1 though?
Well, we have different way to solve it. My way is to use something that I told you before. If a over b is greater than 0, then a greater than 0, b greater than 0. Or a less than 0, b less than 0, right? So for this
Yeah.
one, for me, it's just 1 plus x greater than 0, 1 minus x greater than 0. Or 1 plus x less than 0, 1 minus 1 less than 0.
But like I don't.
And then
Okay.
I can
Okay.
deduce. This one gives me x greater than, let me see, greater than
Oh, you picked the great. Oh, I think I remember this. You picked the greatest thing from each one. This one gives you x is greater than -1, I think. Oh. And this one gives you the wait, no. Oh my God, let me think about this. I'm sorry. It's just it's muddling my head.
Yeah.
No, wait. Okay, never mind. You continue doing it. I can't think.
Okay, so if I deduce, so there is a little like if I do it, I actually don't really use it because I remember something. But I'm not sure you know that. So this is the deducing way without remembering that code pattern. So this is x greater than -1. This one, and this one is x. This is greater than so less than 1. So now this one all together, this two, this one and this one together, you have the
Okay.
x greater than -1 and less than 1, right?
Yeah.
Yeah, and the other one you can't solve it. This is
Right.
x less than -1, right? But x
Oh,
also
but
have a
then
greater than 1, so
also
this
to
one
the
has no
yeah. Oh,
solution,
okay.
right?
Yeah. Okay. I think I understand.
Mm.
Sorry. I don't think I follow. Like, sorry. I don't just don't. I don't think that I think about like the logic of like the negative over negative or positive over positive thing as much as
Yeah.
that.
Okay, so that's this one. So eventually the domain is -1 to 1, right? I read a interval
Yeah.
like this
-1
to
and
1.
1.
Yeah, I can use the number to test. I think it's working. And then let's see this one. Ooh, this one is 1/2 and x. That's the value of x. Oh, that one makes it easy. This is absolute value.
Wait. No. I don't even need to do this. Okay. I think that's just it.
Yeah, that's it. The other restriction is greater than 0 as long as it's not equal to 0. Other real number except 0. Oh, this is graphing it. Because they're inverse functions, so they are symmetrical with y equals x, right?
Yeah.
Then again, yeah. So if it is like 2 to x power like this,
Yeah, because it's like it's the reflection about the line
yeah,
y equals x of y. Okay, yeah, that kind of makes sense.
yeah. So that'll be this one, right? Like this. And if it's a 1/2, if it is 0.5 to x power, there'll be something like this and like this, and then use symmetrical. Symmetry tells us here, right? So this is an increasing function if it's greater than 0. This is a between 0 and 1. This is a decreasing function like this one. Let's see a little bit more here. Oh, they make it, well, make it easy for natural logarithm, right? Because it appears so many places in physics. So instead of e writing it all the time, I can use ln.
Yeah, ln. Yeah, it's ln.
Okay, let's talk about a then. Example 6.
Example 6. Okay. Oh, this is easy.
Yeah.
Okay, so this has to be great.
Yeah, greater than 2 would be
Then
fine.
graph f. Sorry, I think I'm having a hard time wrapping my head around E. Okay, so n 1 over n.
Oh.
What? I'm trying to think about this. Okay.
Hmm.
Let's just say E is approximately 2.
Yeah. Yeah, that's a good question. Yeah. On x minus 2. Yeah.
Oh wait, shoot, sorry. Click the accent. Okay, range and vertical asymptote.
Wait. Oh, wait a second. This is a negative.
Oh right, negative. Okay. Sorry, it took me sorry, I didn't notice that.
Yep. So that'll be a 3.
Yeah, and then the range is give me a second for the range. How do you find the range again? Oh my god.
I think this is the final graphing, right? Like this.
Yeah.
Which means if the range, I can see all the value. I think I can take all the values, right? Is it?
Yeah, all real Y values.
Yeah. Then
All
the
real
range,
numbers.
yeah, the non-real number is the range.
So then f power of -1, that would be could you help me with that? Sorry, it's just taking a second. I don't know.
Oh, you forgot this D?
Yeah, f minus 1. Sorry. I think I can remember. So that like I don't
The
I
easy
don't know.
one that we learned before is, for example, is y equals to 2x. And then I can just make into, there are two kinds of way. One is to make saying x is y over 2. That's kind of the inverse function. We normally write a 1 over 2, right? Does that make sense? This is the easy one. For this one, I can say it's y equals to negative ln x minus 2. I just express my x in y terms.
Oh, okay. Okay, you express your x and y terms, and then that's the inverted version.
and then change the xy then. Yeah. So how do I do it? Well, there is some property that I can use from logarithm. So I can make it e here and make it e here, right? We learn this. There is a property we have to learn later, bro. You later. So I might want to slow things down a little. So if this is y equals to negative ln x minus 2, so I will make it as negative y equals to ln, that property be easier. And then I make an e on both sides. Does that make sense?
Okay. Yeah. Okay.
Yeah.
Yeah. The kind. Yeah.
So
The kind.
e to negative y power equals to, because this one, by the definition, this one is x minus 2.
Equals x minus 2. Okay.
Yeah.
So then it would be from like an x perspective or
Yeah.
something.
So I can move this 2 in there. It's this one, right? I like in the form, this is the inverse function generally, but I like in the form y equals to,
Oh, so do all inverse functions have x?
yeah. We basically switch x and y in the end, or you switch x and y in the beginning, that's also okay. Is it making sense? This is the inverse function, right?
Yeah. Yeah. Okay. Well, how would you switch? How would you switch x and y though?
Well, you can say it's actually this one. Then why we switched? Well, basically x, y, they are just variables, right? But we normally like x to be the variables, to be the independent
Oh.
ones,
Okay.
right? But
Oh. Okay.
that's why
So
we
you
like
just
it in the
put.
form.
So you
We
just
like,
switch it to make it look cool.
yeah,
Cooler,
look
right?
the way that we like it, actually.
Yeah. Okay.
So that's why, yeah, it's eventually it's e to negative x power plus 2, right? And plus 2, right? This is d, right? Does that make sense? Express x in the term of y, using the logic of the equation, and then switch x and y. And also
Yeah.
when you do it, if you do it like x equals to e to the negative y power plus
Yeah.
2,
You just swap variables. It doesn't matter that
yeah,
much.
yeah. And also this one is f negative 1. So f negative 1, if you make it, y, it doesn't really make a lot of sense because it's automatically going for x. So that's why it's better in this form also. So what's the domain then? And range for the inverse function.
Okay, and then the main would be okay. So that's like equals.
Yeah.
Could
Yeah.
you bring it back? Could you bring it back? Sorry, it's
Oh,
taking me a
yes.
second.
E
Equals.
to negative x power. And also this one, when we do it like this, we find inverse function, and then we ask, no, we always normally saying the domain for inverse function is the range for the original function, right? And the range is for domain. Do you remember
Oh,
that pattern?
it's not 0 because I thought the range is all real number. I don't remember that. So the
Uh,
domain is the range of the inverted function, and the range is the domain, and
yeah, kind of. And also we can see it from the graph. See? You see your domain here. Your domain here for inverse function is basically greater than 0, right? Isn't that the range for that one? See? The range for this one? Greater than 0. And also because inverse x into y into x, right? So that's your domain is that range. Your range is that domain. Is that making sense? Do
okay,
you
yeah,
remember?
because it's inverted. So,
Yeah,
but
yeah.
then, but why? Because look, wouldn't it be like x 0? Oh, wait. No, because each curve 0 will just be 1. Okay, that makes sense.
Yeah, kind of. Well, you don't have to. We normally do it like that. If you deduce yourself,
Yeah.
this is the
Oh,
same. Yeah,
okay. Yeah. Okay.
same result though.
Range equals y can't equal 0 because if it equals 0, then that you will have to equal -2 approximately,
Yeah,
and like that just doesn't work if e is the number. It's kind of close to 2 point something.
yeah.
Okay. Now
So,
let me graph it.
hmm.
Okay.
Oh, we can use the graph to check E too. Yeah.
Like approximately that's something. And then
Oh, you can actually use the inverse function rule, symmetrical with y equal to the x2, because you have it here.
oh, okay. So then it would be symmetrical by like y equals x. Okay, so it's like okay,
Yeah.
gonna re so I guess it would look kind of wait, no. Y equals x. So why would I bring it over there? Oh wait, no, that was
Wait.
stupid. I should have put it over there.
Yeah.
Okay, so then it would look like uh something like this, I guess.
If you use symmetrical, which means if this is true, your new asymptote also should
Sorry.
be true.
Oh, okay, yeah. Sorry, it's just I thought y couldn't equal. Wait, can y not equal 0 or 2? Why can't equal 2? Sorry, that was
Mm.
stupid. I wasn't thinking clearly. Okay, so it's 2. So then I guess it's just like this or something.
Wait.
I don't know. I don't know. I'm
I
sorry.
mean, this is symmetrical. Also, it's not that easy. To be honest, when I did this in your like in high school, I actually also used it point by point, kind of. Yeah. But I check it with
Yeah,
y equals
sorry.
x.
I didn't want to go to one before. I was getting lazy.
So this is y equals to what's before is x equals 2, right? This is x equals 2. So the symmetrical asymptote will be here. And what you wrote in here is like this. So it'll be something more like in here. You can intersect with this, and you can intersect with this. So because this one is 3, so this one is also 3. So that's something symmetrical. Although this symmetrical is not easy to draw, though. Does that make sense?
Okay.
So you hasn't your asymptote here is
So
approximate this,
oh wait.
and
So
you approximate
the
this.
range like y can't equal 2, right? So I need to take this. Okay, I'm
Mm,
sorry. I'm trying to think about this. So it's like
mm.
so then you would have to take it point by point, and then it would be like that somehow.
Yeah, yeah.
Okay, yeah. Maybe I could just do it point by point instead of being like
Yeah, some teacher insists that you should draw it, without point by point and just, by
yeah, because I feel like
feeling.
trying to do the symmetrical thing is kind of like it like messes with my brain. Then you see what the asymptote
Mm,
and like the
yeah.
other this thing that thing.
Or you have to move your head a little bit to do symmetrical. Maybe that helps a little. Probably, I don't know. Yeah. So anyway, it's making sense, right? Let's check with E the domain here is here for this domain is all real numbers, right? It's making sense, right? Everything I can take for x value, right? But also for range is greater than this is 2, so it's greater than 2, right? Does that make sense? So E.
Okay.
So this is not x greater than 2. Does that make sense? If you
Okay,
check with
so
the
it's not x. So it's not x greater than 2 because why again? Sorry.
oh well, first is I checked with the graph, and also because when I say domain is the range is the domain. I mean for
Oh
inverse
yeah.
function.
Yeah, it's like sorry,
Mm.
sorry. I thought you were talking about the other graph. Yeah, it is y.
So this is
Like,
the range
it's
for
like
that one, right?
sorry. I know that one's like the one with y equals 2. Sorry, I
Mm.
just kind of sorry, it just confused me for them because you were talking about the other graph, like
No, oh no, this
this
one,
one, the
this one.
original one.
Yeah.
Yeah, okay.
So
Yeah,
this
I get
one, yeah,
yeah, I
also
get
because of the domain, right? The domain you find it is because x greater than 2, and now it just turns out in here is y greater than 2, right? So that's why I said that domain is that range. Does that mean that? And that range
Yep.
is that domain. So normally for this question E, we don't have to find it ourselves. We can always go to find it in question A, because in there I also find a domain, and also easier to find it in the for the range too. You just have to switch it. That domain is the range. Does that make sense?
Yeah.
Okay. Erase. And in the end, you can always use the graph to check it. Also because we have decimals. Oh, and then there's the common logarithm, which is the base 10, right? You remember that one?
Yeah.
Yeah.
Yes, I remember.
Yeah.
Sorry, I didn't
Because
but
we have
like yeah, it is base 10.
yeah, it's because
Yeah,
we have scientific.
that's why like I do the 10 to the power of 2 equals 100. So
Yeah,
log 10 100 equals 2 trick. It's very easy to remember.
yeah. Well, we use scientific notation. We kind of need it 10 base, right?
Yep.
How about example 7 then?
Okay,
Similar as before in the previous one.
okay.
Yeah.
Okay, so then x would equal 0. Wait, no, this is stupid. Okay, so then 2 and okay, log, and then we'll just skip all the way to like 10 over here, I guess. Okay, so 10, wait, 11, sorry.
Yeah.
11, and then now it'd be like, well, that would be, It still does go pretty slowly.
Wait, the original one is like this, right?
Oh yeah,
Log
sorry.
x.
Sorry about the curve. Sorry about the curve being weird. That was stupid.
Yes.
Sorry. I guess it's just been like a while, I guess. I don't know. I'm just trying.
Yeah. And then you move to you move to the right 1 unit already. Good.
Yep, I already moved it.
Yeah.
And then okay. I think the range is just all real numbers.
Yeah.
Okay, so then that would be okay, let me think about this again. Sorry, I let me try to do this on my own. Sorry,
Yeah.
I don't think
Sure.
okay. Okay, I wait, can you show it to me again? I'm sorry, I don't know. I don't know. Can you show it to me again and then can
Sure.
you show like the steps to me again and then after that I'll just try to do it myself. Show me
Okay.
like the steps to like maybe like a generic problem and I'll try to solve it from there.
Okay. You mean when you say show you mean show point by point method, right?
Yeah.
Okay.
Not the point wait, no. I don't mean the point by point method. I mean the answer to number D.
Oh. Okay.
Like how
Sure.
to do that.
Y equals
Yeah.
to 3 logarithm x minus 1. You can
Oh, okay.
use, you can use, you can take it from here?
Wait, no,
No,
sorry.
you can use what you like here. You said 10, 100, and it's 2, right?
Yeah.
Yeah. And the same thing I can use in here. So x minus 1, right? Equals to 3. Well, actually, I have to divide it by 3 to make it easier, right? Is it okay if I divide it 3,
Yep.
right?
Yep, that's fine.
Yeah. And then x minus 1 is
Oh,
10
right.
to y
You
over 3 pi.
divide, yeah. So you basically like you divide it by log, and that equals
Yeah,
like
yeah,
10 to
yeah,
the power.
yeah.
If you divide,
Yes.
so it's like y over log equals 10 to the power of y. Basically, if you forget about the 3 bit, like
Uh,
just like as a simple principle, this bit.
well, for me, it's just that I don't want to see 3. It's complicated, this part. See, this one is easier for me.
Yeah, I know. I'm just saying, like, as a base principle, like, it's like y over log 10 to the power of 10 equals 10 to the power of y. So it would be like y over log n equals n to the power of y. Sorry, not sorry. Okay, whatever.
Okay.
Okay, yeah, I'm gonna try to do it from here. Okay,
Yeah.
so x equals 10 to the power of y over 3 minus plus 1, actually.
Yeah.
Oh, okay, and then you can just make it into. Oh, yeah. Okay, this was
Yeah.
easier when I did it myself. Thank
Yeah.
you.
Yeah. Okay. So yeah, we can summarize from here and
Okay,
from the
domain and
last
the
one.
domain is
3, you have to divide.
yeah.
Otherwise, it's complicated. Looks complicated.
And then the range is y equals 1. Okay, so then I would be and then let me do a point by point. Yeah, I think I get it. I think I get it. Sorry.
Mm.
Oops. I think I get it. Yeah, I think I
Okay.
understand.
So the range is should be the domain for the original
Yeah,
logarithm.
I know. I already wrote it down. It's right here. Y equals 1. Y or like
Wait,
y does not
this is
equal.
x greater than 1. I see x greater than 1.
Yeah, so then it would be
So
y.
y greater than 1.
Yeah, y greater than 1. Okay.
Yeah, I just basically kind of copy it here.
Yeah, so like it's just sorry, I just meant like as in the y, as in whatever. Okay, y greater than 1. How does it work with the y equals x thing if it's greater than 1? Whatever. I'm just gonna do a point by point and see how it goes.
Yeah, point by point, then this I can
N to the
substitute
power
with
of 1 over 3. Okay.
maybe use
Maybe I'll
2,
just,
right?
maybe I'll just go. No, I need to go to 3. 10 to the power of 3 out of 3 is 10 to the power of 1. And that, oh,
Oh, maybe
1.
0.
So that's like
Yeah, 3 is
11.
also good. Yeah, 3 is a good one.
Yeah, and then if you go to 6 next, then that would be like
0 is
100.
also okay.
Okay, yeah. Okay, yeah. I think it just works like this, but it's like really high up.
Yeah, but if it is symmetrical, this one is, I think, this one is 2, right? So this one is also have to be 2. It's kind of like this.
Yeah, I know. Yeah, I know. Sorry,
Yeah.
I know. I put that there.
Yeah, good.
I put that there. Sorry, I just didn't. I just drew it roughly more roughly the first time.
Yeah. Yeah, I'm not used to like point by point now. That's a good one to check. In the beginning, point by point is a very basic method. Is it making sense now? A, B, C, D?
Okay.
Especially you should connect A and E, huh? Find, don't do this directly. Of course, you can do this directly, but we can save it from, or A to B can help us with E, right?
Okay. Yeah. Okay. Let me clear.
No, no. Oh, that's their graphing. Oh, you see, they also
They also
the
have to ask.
intercept. Yeah, yeah, the
Oh, the
intercept.
intercepts. Right. Yeah.
Yeah,
Sorry.
it's a
I
good
saw.
one, right? It's a good symmetrical thing, right? And also it's easy. And if you substitute by point, also the 10 0 power plus 1, 0 trip, that's also good.
Yeah. Okay.
Let's see. Solving the equation. You can still use your like a basic definition. That one.
Log 0 plus 1 is 2.
Hmm.
Oh, 10 to the power of 0 plus 1. Sorry, I did. Why did I say logs? Okay. Sorry, what were you asking again? I was just looking.
Oh, solve the question. Solve X, basically.
Oh, yeah, okay. I was just looking at like the stuff that you wrote. Okay. Let me see.
Yeah. Great. Yeah.
Done.
Yeah. And also everything is okay. About this positive 2 and negative 2, we normally
Oh,
check a
right.
little
Yeah.
bit, right?
Yeah. Okay. Okay. So then I guess both would work. I don't know.
I write it like negative 864.
Well,
It doesn't
negative
really.
8 to the power of 2 still equals 54, doesn't it?
Well, we have a definition. This A part cannot.
It can't be negative.
Yeah.
Okay.
It'll be more difficult to say.
Yeah, okay, I understand.
Okay, let's see next. And how about this? If I solve this, still using the definition,
Oh, E, okay.
e to 2x power.
Okay, and E is approximately 2. So, wait, no, wait, ln. And just,
Yep. Yeah, you can got ln 5 from calculator, right? Then that'll be okay.
yeah, that's like 1.6 approximately. So then
Oh,
let's just around estimate it.
0.8, sure. Oh, here is
Yeah,
a probably word substitution problem. PAC, blood alcohol concentration. Let's do one. Of course, there are too many word problems in this chapter. You don't have to do all of them. Several, maybe. Let's try one.
okay, okay, so like the first question, so like just A.
Yeah.
Okay, percentage of concentration about, sorry, I'm trying to read.
Yeah. Read it. Read it slowly. It doesn't matter. Knowing the background is actually very helpful with that.
Yeah, I know, it's very important. Sorry, I was trying, I don't know why I'm rushed.
Oh yeah. Yeah. Yeah, it's to B then.
It's like 16.8.
Uh, yeah.
Yeah, kind of surprised me that the number was pretty large. I guess like, when you divide it by a decimal.
Yeah. Oh, that's why, yeah, this kind of test is, well, important, I guess. You really increase the risk, even change a little.
Okay, do we have to keep doing the other ones or not?
Sure.
I did, okay. Do we need to though? Because it's like a lot.
Well, I can just say they're basically substitution problem, right? You
Yeah,
find k, you
a
find
lot of
this,
substituting.
yeah.
If it's this, if it's that, then
Yeah, let's just take a look at the answer sheet. You see, you increase to 0.14, and now it's 17.5, right? Yeah. Compared with
yeah,
that, it's actually a lot. It's all kind of just substitution with word.
yep.
Oh, here, finally, it's the property which will make our calculation easier. Are you familiar with this and this one? Familiar with this?
Okay, yeah. So then
No, we don't have to prove it if you're familiar with this.
1, so anything equals 0 equals 1. So
Yeah.
then
Forgot that in exponential function. Yeah.
so then it would be like 1,
Yeah.
etc., etc.
Yeah. How about this one? Do you remember this?
I don't think so, but it seems logical.
We kind of like cancel out. Do you remember there's an f, and f negative 1 is actually x?
Yeah.
Oh,
Really, no. Actually, no, I don't remember.
like
F.
a,
It looks like a
like
T.
it's like the inverse function. It's like inverse eventually it's itself. Does that mean that?
F negative. It looks
Let me
like a
show
T.
you. Y equals to 3. Let's see easier. Y equals to 3x. So an inverse function is x equals to y over 3, right?
Yeah, and then
And
it
then
would
it's
be
y equals to 1 over 3x, right? So if
okay.
I'm using this to test, and then it's the 1 over 3x, right? And then 3x, and eventually it's x, see?
Oh yeah, okay. Okay, so it's like about like okay, yeah, sorry.
It's
It was
kind of
just
like,
kind of confusing. It was just kind of confusing because like the F's I guess look like T. So it was like it's just like classic thing.
f. If I write it completely, it is this, right? Because eventually
Yeah.
it's x, right? Does that make sense? If this works out, if this you remember, and if I don't have to prove that, then I can just use saying, let me see, let's say fx equals to a to x power, and f negative x would be just log ax, right? And then I can use f and f negative x, and just equals to x. So this,
All right, yeah.
this too
Yeah, sorry.
is this, right?
Yeah, I understand. It
Yeah.
does make sense. Like, it's like log AM. It just cancels out.
Yeah, yeah. If you, and it's another cancel out. This is another cancel out, so it returns to R again. Oh, this one is also easier to prove. You can try with the real number. See, 3 and 3 to 4 power. What's that gonna be? 4,
3. Yeah.
right?
Yeah, okay, hang on. Let me do this again. Okay, 3. Oh yeah.
Right?
Yeah, okay, that makes sense. And
So,
then like
yeah.
let's do 3 log 3 4 equals 4 and then 3
Yeah, very nice.
4 equals yeah, that makes sense.
Yeah. If we have this two, we can simplify some of the calculations. Oh, and this, let's do this and then do that one. Well, basically what you did is this one, right? Is it making sense?
Yeah, okay,
I
yeah,
can
it makes
easily
sense.
to deduce that, right? And how about B?
Okay,
Is B
let me
working?
do Yeah, I think so.
right?
Yeah,
Basically
okay.
cancel out,
Yeah, so
right?
it's
This
like
part.
one. Yeah.
And
Give
then
me a second.
C,
0.2
yeah.
to the power of, that'll be 1. Oh, wait, no. This was supposed to have, okay. Yeah, that makes sense. That makes sense now. Sorry, it took me a second to like.
Yeah, it's just this is the second formula. And let's see C.
Yeah,
Is C making sense? Also
so
making
like
sense, right?
ln,
This
yeah,
also
because
cancel out, right?
log
This also cancel
e,
out.
so that would be like e to the power of, yeah, it makes sense. It makes sense.
Okay.
Oh, it makes sense.
And,
Sorry, I keep saying it makes sense.
okay. So there is several other properties. Have you seen this? Product making. This is actually a pretty big thing in math history. Product, multiplication.
Oh, yeah,
Now adding.
log plus, okay.
Do you remember this?
Yeah,
Okay, sure.
yeah, I
This
think I
is a
remember.
big thing. This is a big thing. I'm gonna show you an example why it's a big thing.
A
For
lot of
example,
just review. I guess maybe it's just more difficult if you're like rusty over the summer.
yeah. If this is the product law, this is the quotient law. Do you remember? This is plus. The other one is minus.
Yeah, plus minus the multiply divide.
Yeah. This division
And a log
and
of the power equals the product of the power and the log.
yeah.
Okay.
This one is dropping basically.
Okay, let me do my head.
Hmm.
So that would be like, yep.
Uh, how about 6? Is 6 making sense to you?
Yeah, I think it just all makes sense.
Yeah, I can just put this thing in with because this is making
Yeah,
sense.
because
I can put an X in
Ln,
here, right?
it's like Ln, then just like canceled out the
Yeah,
E.
yeah. Right. So if this all checks, then we can use this. Saying this one. Here, write this big logarithm as the sum of the logarithm express all powers of factors. Can you express this using all the law?
Oh, okay. Hang on. Let me write that. Okay. Let me putting it into action, I guess. Okay. So it's like, yep.
Yeah. And there might be
We're
more to do
both, uh,
because this is square root. I can make it into a 1/2 power, right?
yeah.
So this one can be the second one. This first one, where it can't do anything more. So the second one, it can be writing in something like this, 1/2 power, right? And then I can drop this 1/2 power in here, right? Kind of make it a little bit easier. Is that making sense? Like this.
Yeah, makes sense. Log A, log.
Yeah.
Okay.
Yeah.
Okay, yeah.
This is okay, right?
Yeah, this makes sense to me.
And this is a kind of big thing. This is called multiplication becoming adding somehow on some level. Does that make sense? Which means
somehow does that.
Yeah, if this is true, saying this is
It happens with like exponents too,
yeah, yeah,
well,
yeah.
or maybe something else. I don't know.
Like 444. And then somehow, if this is a big number, right? And then if I somehow becoming this 234, I mean 34 plus 2 and 444, this is much easier. Yeah? Calculating this is huge, right? And talking about the entire thing is even, more difficult. But this one is compared with that is easier, right? Does that make sense?
Yeah.
So that's why this, sum of logarithm is kind of a big thing. It's actually quite a lot of calculation. 4.
Oh, should I do example 4?
Yeah, 4. Differentiable logarithm.
Yeah,
Yeah,
this is.
yeah. And also, we can still simplify it as this 2 dropping, right? And
Oh, yeah.
3
So it's
dropping, right?
okay, yeah.
Yeah.
2ln.
Yeah. Yeah, that's something, right? And then let's do 5. There's sum and differences.
Oh, and the sum. Okay, I need to write out the sum.
Sum and the difference.
Okay, so I'm gonna do the difference first, I guess. So like log a.
Mm.
Oh, and I guess then that would be like it
Wait.
would be net minus 4
Oh,
log.
wait. This you can't drop in 4 because this 4 is
Yeah,
here originally.
I can't drop the 4, sorry.
Yeah.
So it's like 4 instead. Okay.
Yeah.
Sorry, I wasn't thinking. Okay, so that would be minus log 3 plus
Yeah. All right.
okay.
Yeah, if I expand this big bracket, would it be minus this one, also minus
Yeah.
this one, right? And also this 3 can
Yeah.
totally drop. If you separated those two already,
Oh yeah,
3 can
sorry,
drop, right?
I forgot to drop the 3.
Mm.
Also, I think class is over now because
Sure.
you like assigned homework.
Okay, so this is a 5. Can't complete all of them, I guess. Few.
Maybe like an hour long.
An hour long? Okay.
Yeah.
This is page 303. Then from 35 to 56.
Oh, okay, is that it?
Yeah, 35 to 56, and also a little bit more with the previous.
And what?
There's something in another page.
Okay, so what is that?
This is
Do I have to do it?
3. Oh yeah, this is 293. 293.
Which questions?
From 59 to 62. 59 to 62.
Yep,
And
is that it?
then 69 to 71.
Okay, is that it?
Yeah.
All right, yeah, thank you.
Okay, have a good day. God bless you. Bye.
All right, thank you. See you.
See you.